A satellite orbits the Earth, altitude of 710 miles. What is the width of the path on the surface of the Earth that can be seen by the cameras of the satellite? We're going to use 3,950 miles as the Earth's radius. And in this drawing, I drew a sketch of the Earth and I drew the radius and I put the satellite floating above, and you can see the 3D image going back down to the Earth. This will help me label and be able to solve this equation. Now, since the line tangent to the circle is perpendicular to the radius, and if you'll notice, this dotted line here is the line that's tangent. So since it is perpendicular to the radius at the point of tangency, we're going to call this angle alpha. And it's at the center of the Earth and is called an acute angle of the right triangle with a hypotenuse. What is the hypotenuse, the length of this? Well, if it's 3,950 miles is the radius of the Earth, and we're saying that the satellite's floating 710 miles above, we add it up, and then we get the miles that for the hypotenuse side. Okay, so now I know what the hypotenuse side is. Now let's label to the radius, 3,950 miles. Okay, so far so good. So I have a hypotenuse and I have one of the sides of the triangle. So knowing this, I have the adjacent and the hypotenuse. That means I want to use the cosine, because we know the cosine is adjacent over hypotenuse. So let's just plug in what we know. We know that the adjacent is 3,950 and the hypotenuse is 4,660. Now I'm going to just rewrite it like here. Just clean it up a little bit. I need to know what's the angle, right? That's the whole point. I got to find the angle in order for us to go back and solve for the underlying question here. So in order to do that, I need to take the inverse of cosine. When I take the inverse of cosine, now I have this. So I'm going to put it in my calculator, and make sure when you put it in your calculator, you check and put it in radians. And when you put it in radians, and just double check, and I'm going to double check my answer too. So I'm going to take the inverse, 3950 divided by 4660. I'm going to make sure, again, if it's not in radians, you need to make sure it is. And so now I get approximately 0. And I'm not going to round, I'm going to round at least to the 7th place, because I don't want to round too early, because if I do, it might throw my answer off. So I got 5.5592759, and there's a 675. I'm just going to write that down, and let's round. Let's round to this place right here. So if I look at this number behind it, it's going to cause that 5 to go up to a 6, because that 9 is greater than 5 whenever you do the rounding. So this is what I get. So now that I know this, and it's in radians, now that I know this, I can actually go find the width of the path seen on the satellite, right? So I'm going to use this formula that was given to us in these sections, where the surface is equal, and it's actually a small s. I kind of wrote it a little too big. 2 alpha radius. And let's just plug in. Well, I know it's 2 times the 0.559276 radian times the 3,950 miles. And let's just type it in our calculator. 2 times that 0.559276 76 times 3950, and I get 4391.8280 miles. Just be sure and read to see where they're wanting you to round. I'm going to round to the nearest tenth. And you got to be careful because the rounding, if I round too soon, it can cause my answer to be off. I'm going to double check it again. So just to make sure that my answer is right, because there's a good chance I could have, typed in the wrong number or calculated, and I did. I thought the number didn't look right, so I wanted to just double check. And y'all, that's okay if you mess up every now and then. Just always double check. If it don't sound right or look right, definitely go back. It didn't look right to me, so I double checked. This is the actual number. So it's going to be 4,418.3 miles.